Hey everybody, this is Larry. This is me in this is day. Oh, yeah, I just got back from all my travels. You can see on an Instagram. But yeah, this is me doing day 19 of the May Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and of course, at least when I'm in traveling mode, hit me up on Instagram to see what's going on. You'll see the drone shot from earlier. Hopefully, I remember to put it in, but otherwise, you would just be like, "What is Larry's going on?" But yeah, what was the other thing I was going to say? Oh, first things first, I do want to thank all the people from Atlanta and Georgia in general, all my viewers to kind of give me tips. I don't know about, I don't know. Okay, uh, I want to. This is just a general shout out, I guess. I actually forgot to ask them if they would like a shout out, so I don't want to put people's name on the spot or whatever, and accidentally dox anyone. But anyway, thanks for all your input. Been checking out places. Uh, Very happy with some of the photography I've been doing. Though I didn't. The sunset today was beautiful in Atlanta, but I didn't get a good shot. I wasn't at a good place. I didn't have a good. I didn't have a good conversation. Sometimes it is what it is. And the place that a lot of it is just not luck per se, but just timing, right? Like everything else in life. In that, I mean, I'm here in the summer, so the light angle, there's the sun axis or whatever, or the Earth axis really, but and the angles are all a little bit off with how I would like my conversations to be. But you never know. There's still I'm still here for another day or so. So yeah, we'll see. Anyway, that was a long intro. Hope you, if you didn't like it, I hope you skipped it. If not, but yeah. So I want to, yesterday was a rough one. Obviously, the daily contest. I mean, or the daily challenge. These things are. I just want to give you a reminder. These things are recorded live. I do solve them like without seeing them because if I have seen them, that would be just really embarrassing to. Or I don't know. It's a really weird script to get it wrong on purpose for an hour, right? But so I think my goal here is to, of course, try to educate and help however I can with the thought process and sometimes algorithms and stuff like that. But my main focus is to kind of show you that two things, right? One is that I consider myself pretty good. I had a bad week last week, but I was top 100 on Leetcode like 2 weeks ago, say. So I'm pretty good on like contests, real life or real time rating or whatever. And I'm a good engineer, I think. Maybe not, depending on who you talk to. But I think so anyway. And these things still happen. These things, So I think there's something there. And also sometimes in the struggle is where you see all the learning and the creativity, right? Like hopefully that came out and you find it useful because it does come out sometime like this occasionally, but if I knew how to explain everything about problem, that's fine. But I think it's less interesting, maybe. I don't know. Let me know what you think in the comments below or on Discord because people have different opinions. But I think I'd like to kind of show you like all my strengths and all my weaknesses. And yeah, there are a lot of good, fast problems, and you'll be like, oh, of course. But also that I sometimes do struggle. Sometimes just given on reading comprehension. Reading is hard, right? Anyway, okay. So this is a really, really long intro. My apologies if you came just for that. I guess the additional thing is that wow, the stock. I just got back with no internet today. The stock market. What happened there? Hope everyone's doing okay. What a weird year for that, right? Okay. All right, maybe I'll talk more about the stock market another time, but for today, let's focus on today's problem. My apologies if you're here only for the problem. This is a daily solve, but also you're doing it with me, I'm doing it with you. However you want to think about it, I appreciate it. By the way, so let's do it together. Let's get that streak going again. All right. Finally, let's go. Longest increasing path in a matrix, 329. Okay, so given m times n of matrix, return the length of the longest increasing path in matrix. For each cell, you can either move in 4 directions. You may not move diagonally or move outside the boundary. So where do we start? Oh, I guess you don't have to start from anywhere. Okay. There are a couple of ways you can do this. Um, hmm. The way that I like to think about it is by dynamic programming, right? I think that's maybe the most intuitive way. Let's see if there are any constraints just before. So okay, so this is, I think this is not a great, because I think this, yeah, I think so. One core part about so a couple of things, right? One is that this is still a DAG, right? And what is a DAG? A DAG is a directed asynclic graph, and there's no cycles here. Okay, so I guess we'll go, but it's a directed graph because, well, you can draw a line whichever way you want, meaning from a number to its neighbor that is bigger, or to its neighbors that's smaller, depending on which direction you want to go. Of course, for this particular problem, there is symmetry, right? What I mean by that is the longest increasing path is the longest decreasing path. So you could kind of think about it both ways. And then so this is a directed graph, right? Because one pointing at two does not mean there's a, or it given a node one that points at the node two, that actually means that there's no edge from two to one, right? Of course, in an increasing pathway. So that's the second one. And then from that you can try to and then there's no cycles because how do I explain those cycles? Asynclic, I mean, there's no cycles because there's no way to, like if A is greater than B, there's no such, and B is greater than C, say, there's transitive obviously, but there's no such way such that, there's no such way such that C is greater than A, right? In normal, or at least not for the regular numbers. That's probably not the right phrase, but you get what I mean. For numbers that are normal-ish, that's not true, right? So there's no cycles here. And from that means that you can do this with dynamic programming. And you can implement it in two ways. One is, whatchamacallit, bottoms up or top down. For this particular problem, I'm going to do it top down. And we'll go through it together and hopefully we'll, make some magic. Because for dynamic programming, it's just about the recurrence, right? And then the recurrence is, of course, something that is just defines the function. But the better way to get the recurrence is asking the right question. And what does it mean by asking the right question? It means that asking a question or finding the problem, if you want to be technical, where you can express the problem in terms of its subproblem. In the asking the question sense, you want to ask a question that allow us to answer itself in smaller and smaller pieces. And the DAG will obviously help you kind of figure out that in a way. But yeah, so then now here we get longest, maybe XY, right? And what does that do? This gives, I don't know why this is in quotes, oops, gives us the longest path starting at XY, longest increasing path starting at XY, right? So I think that's basically the idea here. Okay. We'll do the caching part or the memorization part in a second. So for now, we're just going to do the brute force thing as well. But that said, let me change that a little bit. Let me take that back, because I think one thing that I've seen a lot, at least on my Discord and discussions, a lot of people just kind of, they implement it in brute force kind of way, and then they add memorization and then hope that it works. For this, you really should at least prove to yourself that this works before implementing it. Otherwise, you just, try, I mean, it's if you have no other way of doing it, I'm not going to judge you on it. Like, it is what it is. You do the best you can, and that's the best you can. But I do urge you that when you do have your own time, like if you're in a contest, you YOLO, it's fine, it happens, right? You get lucky, better than not lucky. If you're an interview, it's a little bit less so, right? So definitely, I definitely urge you to kind of understand how memorization works and how to calculate the space, right? For this one, what are the possible x, right? Is it 200? I think, yeah. So x can be 0 to 200, y can be 0 to 200, right? And then now those are the possible inputs, right? So the total complexity, time complexity first, let's say, is just equal to the total number of inputs times time per input, right? And of course, time per input is just time over input, and then the inputs cancel out if you want to do unit analysis, and then you get the total time, right? So then the total number of inputs. So here, the total number of inputs is equal to let's call this. I don't like this mn, so I'm going to call this r and c, right? So x, let me rewrite this. It's equal to 0 to r, y is equal to 0 to c. So the total number is equal to r times c, right? And then how much work does each input do? Well, and this is, I do this for most problems before I solve it, obviously, but sometimes I don't think I show that in a good way, to be frank, in general. So hopefully this time is slightly better. But each input, I think, well, what am I doing with each input? Well, the most things you can do is go, I think up, down, left, right. Can it go diagonal? No diagonals. Okay. Well, obviously you can move outside. I guess maybe not obvious. Oh, they're weird. But anyway, so for each cell, you're gonna only make 4 calls, right? Up, down, left, right. And keeping in mind that there are no cycles, so really there are only 3 of those directions, because one of the directions you came in, except for the first one, obviously. But that's fine. And that's, a lot of this is implicit anyway, because you can't go back, because then you're going to a decreasing number anyway, right? So that means that, time per input is equal to O of 1. Let's say 3 or 4 checks, right? So in that case, then total time is equal to O of R times C times O of 1, and that is equal to O of R times C, which is linear, of course. Linear in the size of the input, because the size of the input is R times C. And then total space, we're going to do that later, but that's, spoiler alert, it's just going to be R times C, because that's the total, and this is the same idea, right? Total space complexity is equal to the total number of inputs times space per input. In this case, space per input is going to be O of 1, because we just use, one where, sorry, my allergies are started acting up again. I need to do my Benadryl. But anyway, so then in this case, times O of 1, and that's going to be O of R times C. Oops. Wrote that in weird, right? Yeah, okay. Okay, so I did this very quickly in my head. I'm like, okay, so that sounds good. So then now, this is when I actually implemented. Everything you see here, I did in my head very quickly. Some of it is just from experience, right? Like from experience, I know how to do this in my head very quickly, because I recognize it, right? But if I were to kind of articulate it out, this is what I would do before coding, to emphasize it, right? So okay. And this is a memorization. If we don't, then it's going to be exponential, because now each time per input is exponential. And is it? I don't know. Well, it probably is, because it's 4 times whatever, 4 to the whatever, rather. And then space is 4 to the whatever as well. Actually, I guess space, you don't use extra space because you're not memorizing. But anyway, yeah. Okay. So the other thing I want to do before, maybe I don't cut it off. Okay. It's just set directions, and this is something that I do a lot, right? It's just setting up the 4 directions. I think I don't know how I feel about this anymore, but it used to be pretty, like, just fundamental, right? So okay, so then now best is equal to 1. This is our default best. This is our base case, if you will. Basically, if we can't go anywhere else, then our return best. We can't go anywhere else. We are at 1 space, because the longest increasing path has 1 node, which is itself, right? And then here, so this is an implicit base case. And then now we do for dx, dy in directions. Hopefully this is similar to what you've seen from me in breadth first search, depth first search, stuff like that. Or not, sorry, not that stuff. I just mean like grid-based problem. This is very gritty type of thing that I do almost every time. So yeah. And then we just check that. Oh, I didn't write this. Always you go to length of matrix. I love setting the things first. Make sure that is at least 1 so we don't have to check for it. And then now we check that nx is within bounds and y is within bounds, and then also that we're going to an increasing number, right? So that means matrix of xy is less than matrix of nx and y, right? If this is the case, then best is equal to max of best longest of nx and y, and that's pretty much it, except for the caching part or memorization part. But that's basically the direction, right? Like you go, okay, what is the best way? What is the longest increasing path starting from xy? Well, is this? Oh, whoops! I did mess up. Sorry, friends. Is the adjacent node, if it's increasing, go to the next node plus 1. That's basically the idea, and that's pretty much it. Yeah. Yeah, okay. And then here, for best, we just have to figure out which cell to start from, right? And the cell to start from is just going to be, well, you don't have to guess. You just try all of them. So yeah, so this is what we're going to do. Right? Oops, and best, of course. And that's pretty much it. Of course, this will time out, but I'm just going to run the code just to see if it compile errors or something. Not compile errors, but you know what I mean. Oh, this actually doesn't time out. But I mean, for bigger cases, it would definitely time out anyway. Okay. Syntax error was just the word I was looking for. But anyway, so now we just have to memorize, right? And the way that I like to memorize is just, for every possible input, the idea here is that if you give the same input, you should get the same output every time, right? And so for that, you memorize so that the next time you do the same input, you already know the answer. So just return it. That's basically the idea. I call it cache for that reason, because it's like storing it on cache. But that's up to you. Whatever, right? And then here now, all we have to do is go if has cache. That means if we already cached this, then return cache of xy. At the very end, we go has cache xy is equal to true because we have it, and then cache of xy is equal to best, and then return. Before it was 44 milliseconds, something like that, I think. I don't know if it's gonna be faster. I mean, it is slightly faster, but we don't have a big case, right? So maybe we could have a big case just for fun. Or like not a big case, but at least a bigger case. So then we could kind of see the difference a little bit. I don't know if this is that good, but yeah, let's get rid of the cache for now, so we don't set hash cache to be true. So there's no cache. Let's see if this is fast enough. Yeah, I think this is actually fast enough because of the DAG, but wow, this is actually faster than I expected. Okay, well, nonetheless, if we have hash cache, is it that much faster? Okay, I failed in the illustration, but nonetheless, it is faster. But let's say I have a really big case, that'll be true. Okay, I think what that left is me just double checking if I have any silly mistakes. Let's check this one. Yeah, okay. Let's give it a submit then. Apparently I did it twice before. One time error once, I don't know how, but let's take a look at that. And there you go. There we have it. Completion streak 779 days. This time I did the analysis first, so hopefully that makes sense. How did I get a one-time error? Dum dum dum. Huh. Oh, I just missed the empty space one. What is this? Oh, this is me doing bottom up. Okay. I guess that's fine. Maybe I was just trying to be fancy. But yeah, that's pretty much all I have. Let me know what you think. This is the first half. This is the second half of the code. Yeah, I'll see you later. Stay good, stay healthy, take good mental health. Take care, and I'll see you later. Bye-bye. Bye.